Hello, my name is Matt Gracie, and I'm an engineer on the professional services team at Security Onion Solutions. In this video, I'm going to be demonstrating the alert-driven workflow for investigating potential incidents using Security Onion. This is the most common way for an analyst to leverage the platform by reviewing the alerts generated by the various components of Security Onion and assessing them as potential threats or problems. Just a note, for this demonstration, I'm going to be using the Security Onion Analyst platform, which can be installed from the Security Onion ISO using the SO Analyst install command. Most of what I'll be doing is through the web browser, so you should be able to follow along with another platform if you don't have the Analyst image installed. Let's get started. Let's start by logging into the Security Onion console, or SOC, using the username and password that you established during installation. When you log in, you'll initially see the Overview screen. Along the left-hand side of the web browser window are links to various subcomponents of Security Onion. For today's exercise, we're mostly interested in the Alerts pane, the Hunt interface, which will help us with our investigation, PCAP, which will allow us to drill into packet captures that Security Onion has taken off the network, and the Hive, which is our case management and investigation tool. To get started, we'll click on Alerts, and we'll see the interface presenting all the alerts that have been raised in our environment in the last 24 hours. As you can see in the top right, there's a time selector. It's last 24 hours by default. You can click on the number to change it. You can click on the unit of time to change that. Or if you click on the clock icon to the left of the word last, you can change it from relative to absolute time if there's a particular time frame that you would like to look at. This interface is a clearinghouse for all the alerts raised by the various pieces of Security Onion. As you can see, by default, it's sorted by rule name, event module, and event severity. The table at the bottom has a count, which is how many times the alert has been raised in the preceding, in this case, 24 hours, the rule name, which denotes why the alert was raised, the event module, which says which subcomponent of Security Onion raised it, and the severity level, which indicates how critical the alert is. The event modules in this case include Suricata, which is our network signature-based IDS component, Playbook, which is a Sigma-based component for doing detection inside of logs, and OSEC, which is the event module that ingests Wazoo endpoint IDS data. In this case, we have 2 high-severity events, we have 3 medium-severity events, and we have 3 low-severity events. It's probably worth noting that these severities are just a best guess by the rule author, so you can change them for your environment if something is higher or lower priority than they consider it to be in a general case. On the left hand of the table, you see there's a bell icon and also a triangle. The bell icon is for acknowledging alerts. For example, this curl user agent outbound, if that's a normal piece of network activity in my environment, it's not something that merits further investigation, I can click on the bell icon to acknowledge it and it will disappear from my alerts interface. It disappears from the interface for all analysts, so this means that it's been looked at, found to be a false positive, and does not need further investigation. If something does need further investigation, then I can click on this blue triangle icon for escalate, and it will open a case in the Hive, which again is our case management and record system. Looking at the alerts that we have here, it looks like we have some sort of net issue right here. We have a net user command response. We have a security event log being cleared, which means on an endpoint someone cleared the Windows security event log. We have a couple more of these attack response alerts. We have what appears to be a generic web shell alert. We have some low priority system audit events. We have an RDP connection being confirmed. And we have somebody using the PowerShell user agent, which means they were probably doing something like a wget using PowerShell to an endpoint. Starting at the top, if we want to investigate and get more details about a particular alert, we can click on the alert name and then click drill down. That will change the focus here to focus on a particular rule name. And then if we want the details, we can click on the caret to expand it and get all the details that Security Onion retains in its backing database about this particular alert. Now, this being a Suricata alert, probably the most interesting pieces of information are the source and destination IP, the source and destination port, what the signature or rule is, and what the traffic is that caused it to trigger. Scrolling down, we see that our destination IP is 138.92.1.100. That's an endpoint that is outside of my network, so this is somebody on the internet coming in. We see that the source IP down here is 192.168.1.15. I know that in my environment that's a web server running Windows 2012 and Apache, so that is where the traffic that caused the alert is coming from. I see the rule here, so it's telling me to alert on any TCP traffic that includes the content user accounts for such and such. So this is a rule that is designed to alert when seeing that traffic. Now if I scroll up a little bit, I'll see the actual network traffic that caused the alert, in this case network data decoded. It looks like an HTTP response coming from my web server. HTTP 200 OK, so it's an OK response. It's coming from my Apache server running PHP. It looks like a response to a post to a PHP script called standard.php, which is not something that I'm familiar with. It's not something that's common in my environment. And the response contains a list of the user accounts on this web server. In this case, there are 5 accounts. They're called administrator, backups, guest, Jimmy, and Teddy. So what this alert is telling us is that the output from a net users command is going out from my web server over port 80. Generally speaking, this is indicative of a web shell. That is a piece of malicious software that's been installed on my web server to offer shell access to an adversary on the outside so they can issue operating system level commands to my web server. That's probably not great. It's a sign of compromise, so it merits further investigation. One quick thing that we can do is click on this IP, which we believe is the adversary's IP, click on Only, and that will give us all the alerts that include that IP address. And looking over the alerts that we have here, it looks like it confirms my suspicion that we've got a web shell. We have a couple more of these command completeds. We have our initial net user command response. We have a couple of these web shell ones, and we also have an RDP connection coming from that IP address into our web server. So we'll need to follow up on that later, but it looks like what may have happened, if we sort by timestamp, is there was an RDP connection from that IP to our web server, and then we started getting these web shell alerts. So somebody probably exposed RDP to the internet, an adversary was able to log in and install a web shell, and then they were doing some more nefarious stuff via web shell. If we go back to our standard view, we see that this net user command response definitely merits further investigation. It's backed up by a bunch of other alerts. So we'll click on the blue triangle for escalate. That'll take a moment, and then it will open a case for us in the Hive. We go to the Hive. And we see that this case was opened. It's case number 15, and it was opened with the title of the rule that fired, ET attack response, net user command response. Now again, the Hive is for case management and tracking our investigation. So we'll open up this case. And then we will put in that IP address as an observable. Observables are what the Hive calls artifacts that you discover during your investigation. So type is IP. The value is 138.92.1.100. We'll also put the IP address of our web server in here that was potentially compromised, 192.168.1.15. Description, possible web shell IPs. And then we will create the observable. Now the reason why we want to do this is because the Hive is smart enough to compare observables between cases. So if we put our observables in every time we make an investigation or every time we evaluate an alert, then it will build relationships between these cases, and you can look for trends where certain servers are getting compromised over and over again, or certain outside IPs are attacking us. It'll just allow you to sort of enrich the context around your investigations. So that's our observables that are in there for now. Let's go back to alerts. Now this security event log cleared coming from Playbook, this is very worrisome. This means that in the endpoint logs on that box, somebody was clearing out the event log. And if we scroll down, we'll see the event data message, because this is an endpoint log. We don't have that network data decoded field. And it says the audit log was cleared on our Win 2012 web server by an account named administrator. So somebody got administrator access to that box and used it to clean out all of the endpoint security logs, trying to cover their tracks. So we'll come back to that in a little bit, but that's another alert that's very worrisome. If we look here at the command completed, we can drill down this way. In this case, this alert fired 4 times, and we have network data decoded coming back, and it has net user / add backups password, the command completed successfully. So somebody used that web shell to create another user named backups on the web server. If we want to see exactly what happened, we can click on this, go to Actions, and then PCAP, and it will show us the full packet capture for the interaction. Somebody posted to standard.php, they posted the command net user add backups password, and then the command completed successfully comes back in the HTTP traffic. So somebody connected to this via the web shell and used it to create an account. What we can do at this point is go back to our attacker IP, click on that, and then open a hunt in a new tab. So if we middle click on this hunt action, it will give us all of the information that Security Onion has recorded involving this IP address, grouped by the module and data set. We have a lot of different Zeek data, meaning network metadata that was captured by the Zeek IDS. We have some more Suricata alerts. We have some Windows event logs from the security log. We also have some sysmon logs because our web server is submitting endpoint logs via sysmon. So if we go up here, we'll say Zeek, HTTP include. We want to see all of the HTTP traffic involving this IP address, because this is the IP address that is submitting commands to our web shell. And then we can group them by the HTTP method if we want. So scroll down here and say HTTP method and click on this little stack of papers that will add it to the group in the hunt interface. And then at the top, we'll say, okay, we've got 8 post commands. We've got 2 get commands. This being a web shell, the post commands are the ones that we're interested in. So we'll click on that and click include. Make sure it's properly sorted by timestamp. And now we have everything that was posted from 138.92.1.100 to 192.168.115 over port 80. So we can see the user agent. This is apparently coming from a Mozilla install on Fedora. We can see all of the log information. What we can't see is what's actually being posted. To do that, again, we need to pivot to our PCAP. So we can click here, go to PCAP, open that in another window. And the first thing that was posted was, who am I? So this web shell was installed on the box. Somebody connected it from the outside, ran who am I, and in the response we can see that who they are is administrator. All right, so pieces are starting to come together now. We know that there was an RDP connection from this attacker IP to the web server. Immediately after that, there was a bunch of web traffic from the same IP address to our web server over port 80, going to this standard.php script, which is most likely a web shell. And the first thing that they ran was who am I, to determine what sort of rights they had. Whoever administers this box set up Apache as an administrator user, so that means that this web shell is giving them basically free reign over the whole server. So as we're observing things, we'll go back into the Hive, we'll add our observable. File name is standard.php. That is our web shell. It has been cited, and we'll create our observable. And that adds it into our list of observables here in the Hive for case management. Now, obviously, if we have a web shell in place, there's two things that we want to determine. One is, what else did the web shell do? And the other is, where did the web shell come from? So we can tackle those one at a time, and again, do it all within this Security Onion alerts interface. So they posted who am I initially, and then the next thing net user add backups. So that's the user backups being added. Close out these old ones. And then the next thing was adding that backups user to the local administrators group, net local group administrators backups/add. And again, the command completed successfully. When we're looking in the PCAPs, the stuff in the blue is from one side and the stuff in red is from the other. So this is what's being submitted in this web shell form, and this is what's coming back. So looking at these network logs step by step, we can see each command that was being executed from that source IP to the web shell. If we want to do it all in one go, we can do a larger PCAP through the PCAP interface here. So we submit, and we put in the sensor name, the source IP address. We're looking for traffic on port 80, anything that was exchanged this day. We put all that in, we submit, and then we can look at the full packet capture of all the port 80 network traffic from that endpoint to our web server over the course of the day. So the first thing they did was download the favicon and the other stuff from the web server. Then they posted to standard.php, who am I? And we know that executed and returned administrator. Then the next thing they executed was that net user add backups. We see that executed successfully, so they added the backups user. Then net local group administrators backups add, adding that backups user to the local administrator group. That completed successfully. Next thing was net users, to get a list of the users on the box. It now includes that backups user, and this is, as you can recall, the high priority Suricata alert that we initially started investigating. Next thing was net local group administrators, to list the members of the local administrators group. And that came back, administrators have complete and unrestricted access to the computer, and includes administrator, backups, the account that they just created, Jimmy and Teddy. So those are all the administrator accounts on the box, and thanks to the web shell, our adversary was able to install a new one named backups. Then they ran Windows Event Utility Clear Security to clear the security logs on the box, which was successful. As you recall, we got a playbook alert for that. And then they ran Clear Application Logs, which was also successful. And finally, they ran a recursive delete on the Apache log directory. So that was also successful. So altogether, what did this intruder do? They connected to the web shell. They ran who am I to determine what context the Apache service was running under. They created a new account named backups with an arbitrary password. They put it into the administrators group. They checked to make sure that all that was true, that everything had worked. Then they cleared the security application and web server logs in an attempt to cover their tracks. So this is a skilled adversary attempting to establish persistence on this box. It doesn't look like they've done anything else, at least not from that IP. It doesn't look like anything else has been exfiltrated, but we definitely want to get this cleaned up and button up the RDP hole that they were able to exploit to get in there. Now, a question you may be asking at this point is, what if this was all going over port 443 instead of port 80? If this traffic was encrypted, I wouldn't be able to look in the packet captures and see all the commands and see what's going on. So is there another angle of attack that we could use that doesn't involve the network logs? And the answer for that is yes. So we'll close this hunt window here. We'll go back to our alerts. Go back to the standard view. And as you recall, we have this playbook alert for security event log cleared. Now, the way Playbook works is it uses what are called Sigma rules, that is, vendor-agnostic rules, to search the log files retained by Security Onion looking for particular characteristics. So if we drill down in this one, we'll see the full event in this message field. The audit log was cleared. It was cleared by an account named administrator. It was cleared on Win 2012 Web, which is our web server. It was related to Security Onion using WinLogBeat. These logs can be collected via Windows Event Forwarding in a larger Active Directory domain environment, or they could be forwarded off the individual machine as they were here. But in any case, the endpoint logs are natively supported and parsed by Security Onion. So this all got pushed into our Security Onion environment. And then we have a playbook that says if you see event 1102, which is the security log has been cleared, then raise an alert in the alerts panel. So even if this was happening via a encrypted connection and we couldn't eavesdrop on the web traffic, we'd still be able to see this from the endpoint logs and know that the audit log had been cleared. So from here, we can go down to our administrator name. We can click on that. We can open a hunt under the name administrator. And we'll see these are all of the administrator related logs that we have for the last 24 hours. If we want to see everything else that was done by that account, which means by the web shell, we can click on process creation and include to add that to our query. Open up the first one on the list here. We can sort by process command line, or group by rather. So if we look at this, we'll add a timestamp to make it a little easier to sort out. We see all this stuff here. It's sorted by timestamp. We see at some point administrator ran this werfault.exe. I think that's unrelated to this incident. Then at 12:50:31, which matches some of the alert timestamps, we see this whoami command. And as we know from looking at the packet capture, whoami was the first thing that was run. So whoami executes, and it actually executes 3 times because it's executing from the web shell and then being relayed to command.exe and then actually executing. We see the net user add backups. We see the local group administrators backups add. We see the net users. We see the net local group administrators. We see the clearing of the 2 event logs, the security log and the application log. And then we see the deletion of all the Apache logs. So even if the web connection itself were encrypted, as more and more of them are these days, if you're bringing endpoint logs into your Security Onion instance, you're able to do the same sort of investigation, and perhaps more importantly, you're still able to alert on suspicious behavior if you're engineering your detections to look out for this stuff. That playbook alert about the Security Onion security log being cleared in your Windows environment, that's still going to come up even if the web stuff is all being encrypted. All right, so we know what was done with the web shell. So let's create some tasks here in the Hive and tell people what needs to be cleared up. So web team, you need to remove that standard.php from the Win 2012 Web htdocs directory. So we'll put that in the Hive. It'll be assigned to the web team, and then they can do that task. Next group, server team, you need to remove that backups account from Win 2012 Web. That is the additional account that was created by the adversary as a means of persistence. We don't want that on there. And then let's go back and figure out how the web shell got onto the machine, and then we'll probably have some more tasks. So let's go back to the Hunt interface and figure out how this got on the box in the first place. We'll change our query here to the name of the web shell, which was standard.php. We can wipe out the process command line because we're not looking at PowerShell logs anymore. We'll search for that. And we see that we've got a bunch of Zeek logs and those Suricata alerts. But the first thing that we see, and the first thing by timestamp, is a PowerShell log. This web server is sending PowerShell logs, just like syslogs and Windows event logs, straight into Security Onion for parsing and interpretation. So that's what this is. We have a PowerShell command with standard.php in it. Let's add that to our query with include. Open up the details of the event in our Hunt view here. And we can see that the script block text, that is the PowerShell command that was actually being run, is invoke web request, URI, this IP address, /foo.php, and writing the file standard.php to our htdocs. So this is the point of entry for the web shell into our environment. Somebody on this web server ran this PowerShell command. It's sort of like a Windows version of wget to pull down a piece of PHP code and write it into the htdocs directory that's being served by Apache. So our best course of action then would be to figure out who exactly that was and what else they ran on this box, just to make sure there's no other surprises waiting for us. If we scroll down, we'll see that the Windows username is Jimmy. So the Jimmy account was the one that was being used for this. We'll click that and we'll click include to add it to our query. We will remove standard.php because now we're looking for everything that this account did, not just stuff related to standard.php. And now we can get a list of everything that the Jimmy account did in PowerShell. We'll open one of these up. We'll add the script block text as a group field. And now, since everything is ordered by timestamp, we have a command history from PowerShell of everything that this Jimmy account did on this box in the last 24 hours. They logged in, they received the prompt, they ran net user, listing the users that are on the box. They ran get service to find out what services were operating on the box, what kind of server it was. They ran get process to see what processes were on there. They attempted to add this backups account, the one that was later added via the web shell. This must have failed either due to EDR or some other security measure on the endpoint. They got a directory listing of the C drive, C/departments to see what sort of data was in that directory, C/examp3 to determine whether this was Apache, and if so, what's in the htdocs directory. They got a directory for program files and for program files x86. And then here we see the download of the web shell. So this is the invoke web request URI with the IP address /foo.php. They then attempted to clear the security log and then logged out. So this was a very fast attack. Took about 3 minutes from first to last command, but they were able to log in, do some reconnaissance, install that web shell, and then log out. If we want to get a copy of the web shell, one of the best things we could do is get this IP address, use that as our Hunt query. So we'll just erase all this stuff and put in the IP address, group it by event module and dataset. And you'll see we have one file record for this IP. If we include on that, you see it is a PHP file as we suspected. Here are the hash values. So if we want, we can add those to our observables in the Hive. So if they show up elsewhere in an investigation, we'll be aware. And then going back to the Hunt screen, we can click on that value. We can go to PCAP, and we can get a view of the actual packet capture for that PHP file. So looking, we see the get foo.php. It's coming from the PowerShell user agent from that Windows 2012 server, and then coming back from that 3. Apparently this is also an Apache server, and it is a PHP web shell file, copyright 2017 by White Winter Wolf. So this appears to be just an off-the-shelf GitHub PHP web shell that somebody installed. It's even got a copy of the GPL on it. But now that we have the file hash and the various file names in our observables, we'll know again in the Hive if it shows up somewhere else. So we can go back, we can add a couple more tasks to the Hive. We can tell our server team, you need to reset that Jimmy password. That's the one that was compromised and was used to install the web shell. We can also tell them to remove the RDP access from the internet to Win 2012 Web. That should close the hole that was used with the compromised credentials in order to install the web shell. Then we have our earlier instructions to remove the backups account and remove the standard.php web shell file. Once those are all done, this incident should be resolved. We can close it in the Hive, but the observables, again, will remain live. So if they show up in another investigation further down the road, we'll be able to look back at our notes and see what we've done. So, to summarize, what have we done today? Starting with the alerts raised by Suricata about a potential web shell, we were able to hunt that down using the hunt interface and our PCAPs to determine what the web shell was, where it had come from, what compromised user account was used to put it on our web server, what commands were run by the web shell, and what other damage might have been done. We were able to record all this information in the Hive, including inputting observables so that we can cross-correlate against other potential cases, and build a remediation task list for our web and server teams to clean everything up. All of this started with an alert from Suricata, but using the various tools in Security Onion, we were able to build additional context, a timeline of the event, and figure out what we need to do in order to respond to the incident. I hope this was helpful. Thanks so much for listening.